Hello, my name is Mariam Shahzad and I am a data science and business analytics intern at Sparks Foundation. And here I am presenting my task 2, which is about k-mean clustering, and it is an unsupervised machine learning algorithm. First of all, I am importing all the important libraries. And secondly, in this task, I am going to use the iris dataset. I am just loading the iris dataset and here predicting the head of the dataset. Basically, there are four input features in iris dataset, which is sepal length, sepal width, petal length, and petal width. On basis of these four features, we are going to predict the type of iris. There are three types of iris. First one is setosa, second one is versicolor, and the third one is virginica. Here I'm just analyzing my dataset by just viewing the count, mean, maximum, and minimum by just using the describe function. Here I am printing the basic information about my dataset. Here you can see how many entities are there in my dataset, and for each feature there is no any null value. There is not any null value. Now basically what the task is. In this task we are going to find the optimum number of clusters for k-means. Now the question is, how does one determine the value of k? Here we will use the elbow method. In elbow method we will run our model for different values of k, and through graph we will analyze what will be the best optimum value for k. Here in X there is all my input features, and from scikit-learn dot cluster I am importing k-means. Here I am making an array which is empty, which is within cluster sum of squares. Basically WCSS is for within cluster sum of squares. In this array we are just appending our result for each value of k. In this loop the k value will range from number of cluster value will range from 1 to 11, and we are fitting our training dataset in our model and appending the result in the within cluster sum of squares array. Now here we are presenting the graph. In this graph, in x-axis there is a number of clusters which are from 1 to 11, and in y-axis there is the within cluster sum of square value. So basically how we find the optimum value of k. So we can clearly see why it's called the elbow method from the above graph. The optimum cluster is where the elbow occur, and in this graph we can see their elbow occur at this point, which is 3, and it occur when our within square sum of square does not decrease significantly with every iteration, and where our graph will be starting constant. So basically at point 3 our graph is going constant. Now we are training our model just with the value of k, which is 3, which we just choose from our elbow method, and we are here using the fit and predict method, which will train the model and test the model at once. Now here we are realizing the clusters. So in this graph you can see there are different scatters for each type of output. So the first one is for setosa, the second one is for the versicolor, and the third one is for virginica. And lastly we are printing the centroids of our dataset. Here you can see the yellow points show the centroids of each type of flowers. So basically that's all. If you have any questions you can ask in comment section, and thank you.